Hello, everyone. Welcome to another Sunbelt Spotlight. And today's program is very dear to my heart. It's about one of my very favorite, and I should say my most favorite area anywhere in the United States or around the world. It's Anza-Borrego Desert State Park. And today, I'm just totally delighted to be able to introduce Mike Wells. He is the co-author of this book with Marie Simovich. They worked for decades on this book, and it is the ultimate guidebook to really understanding this desert area and really getting to know the natural history of the area. Now, Mike really got interested in Anza-Borrego way back in 1977, and I think I met him just about that time when I was doing research in the Anza-Borrego area. He was a state park ranger and then continued on his career with California state parks, moving to different parks, came back to Anza-Borrego as the superintendent of the Colorado Desert District, where he supervised several parks, including Anza-Borrego State Park. While he was doing this and his career was advancing, he was also going to school, and he got a PhD, a program between Santa Barbara and UC San Diego, and he majored in geography and became interested in forest fires, and has become an fire ecology expert. So he has that also under his belt. He partnered with Marie Simovich at University of San Diego for over a decade, teaching classes on the natural history of the Anza-Borrego area. When he came to us, when he and Marie came to Sunbelt to introduce the idea of publishing a book based on their years and years of research and teaching about the natural history, we were absolutely delighted, because this is a book that has been waiting to be published, and it is the book. It's readable, it's encyclopedic, and you not only learn about this area, you learn about deserts in general, how animals adapt to the area. Very, very exciting book, and I'm very excited to hear what Mike is going to be talking about today. Incidentally, what I want to also mention is that if you look on our website, we have discounted the book for this talk. And if you're interested in getting a copy of the book, be sure and take a look at the website and take advantage of the discounted price. The format here is Mike will give the program, and afterwards we'll have a Q&A. You can type in some questions that you have down in the chat area. We'll read them. Mike will be able to respond. And then we'll kind of tell you about some other upcoming spotlights that we have in the next couple of months. So right now, it's my pleasure to introduce Mike Wells and to hear the story of the Anza-Borrego book and how this came about. Mike, take it away.
Thank you, Diana. And I just wanted to say, when my wife and I wrote this book, this was our first book. This is our first rodeo, so to speak, and we're very happy to have Sunbelt take it. And they really are the pros. I mean, and they did a wonderful job on the book, and we're very happy. As Diana mentioned, my wife and I taught a class at University of San Diego, and for 17 years, and the core of the class was taking the students out to Anza-Borrego for a week-long field trip during spring break. And I can say we had a lot of fun teaching the class, and I think we met a lot of great kids that have gone on to jobs and careers. And my wife and I wrote the book, and Diana was the editor. And like I said, this was our first book, and it took a lot of editing to get into shape for publication. But the illustrations that you see, the infographics, were done by Diolinda Montiero, one of my wife's former students. And then the fine line drawings were done by Annie Kowalski, who is also our niece and has a degree in art from University of San Diego. And this, I won't go completely through this, but I just want to say that the book is broken into two halves, and one is the abiotic environment. And what we may mean by that are things like climate, weather, geology, and geography, and how they have influenced the Anza-Borrego area and why it is a desert. And the second part is the biotic environment, the plants and animals that live here and how they're adapted to the desert, and also the interactions between different species and groups of species. And people have very different visions of what the desert is. I remember a few years back, somebody as an art project hung a plaque on the monument that divides Imperial County from San Diego County on Highway S2. And what the plaque said was, this is the desert. There's nothing here, absolutely nothing. And of course, those of us that live out in the desert know that that's really a misconception, that there is an abundance of life in the desert, and it is very diverse. And the plants and animals that live there have taken a real broad diversity of evolutionary paths to kind of get where they are. And what is a desert? It's a land of extremes, especially in both temperature and water either in its abundance or absence. And it's an area where evapotranspiration exceeds precipitation. And what that means is that the power of the sun to evaporate water is actually greater than the amount of precipitation that falls. So there's sort of a moisture deficit. And also the soils in the desert, because plant life is fairly sparse, tends to be very light in organic matter, and also tends to be high in salinity and alkalinity, which calls for adaptations on the plants that live here. And temperatures vary both daily and seasonally. Because we have generally clear skies, we get a lot of insolation during the day, meaning a lot of sunshine. And then at night, because we don't have many clouds, a lot of that heat is radiated away. And so we have a huge variance in temperature. While I've been here, our coldest temperature has been 14 degrees Fahrenheit, and our warmest is 123. And one thing that you see in different deserts is convergent evolution, meaning that the plants and animals that live there tend to be similar, even though they may not be closely related genetically. As an example, in the Western Hemisphere, in the New World, we have cacti, and that's a family of plants that is unique to this hemisphere. In the Old World, they don't have cacti, but they have plants that have radiated into that niche, and plants in the family Euphorbia. And if you go to Africa, you can see a large euphorbia called the candelabra tree that looks quite a bit like organ pipe cactus. And they're completely unrelated genetically, but they look quite a bit similar physically. And then also other animals like the finnick fox in Africa and the kit fox look very similar, have long legs, long ears, and small body size. But again, they're only very remotely related within the foxes. And also we have the jerboa in Africa and the kangaroo rat in North America, and the Saharan horned viper, which looks an awful lot like our sidewinder, except it has no rattles on its tail, but the horns are actually flaps of skin that go down over their eyes when they travel through the sand. And that's the same thing that you see in sidewinders as well. And they both move by side winding. I'll talk a little bit about that later. And we look at climate first on a global scale and how things like variations in the tilt of the Earth and variations in the Earth's orbit have influenced the development of climate over eons. And then we also look at it at a local scale, how things like rain shadows. And here in Anza-Borrego, we actually are part of two rain shadows, one from the west, the coastal mountains, and then one from the north, from the transverse mountain ranges that keep moisture from the Pacific Ocean from reaching this area. And we also talk about things like clouds. And on the left there, you can see lenticular clouds, which are about my favorite weather phenomenon to see. And they're caused by streams of air that are deflected upwards, usually by mountains. And then as the air travels upward, it cools. And as it cools, it'll reach its dew point. As it does, it'll produce these clouds. So the clouds stay in the same place, even though the air that brought the moisture there is moving. And actually, you can see things like stacks of lenticular clouds that'll form each time that the air reaches the dew point and produces a cloud, and it'll have less moisture, so it'll go up higher, and then it reaches its new dew point, and another cloud will form, and so forth. And so you'll see these stacks that look like stacks of aerial pancakes. And on the right, we have a cumulonimbus cloud, and they are the clouds that bring us rainfall usually. And we also talk about atmospheric and oceanic circulation, and something in particular called a feral cell right here that affects us a lot. A feral cell is moist air that rises over the equator or close to it. And as it rises, it produces rainfall in the tropics. Then it travels either north or south of the equator. And about 30 degrees latitude, it starts to descend again. And so in areas like Anza-Borrego, we tend to get these persistent high pressure cells that are formed as part of the feral cell, and that fends off storms from reaching us from the Pacific Ocean. And we also talk about processes, geological processes that have created our landscape, one being orogeny, which is just mountain building. And here in California, and actually all along the Western North America and Western South America, we have subduction taking place, which means the oceanic plate is actually diving beneath the continental plates, and that causes volcanism and other phenomena. And then also we have in this area an area of expanding crust that's centered on the Salton Trough. And so as the crust expands, it forms alternating ridges and valleys, and you can see that in the topography of Southern California. And we like to show examples of where you can see these phenomena actually in the park. And one of them, and can everybody see the entire slide on the right? Because actually, okay, this is actually a view from the desert overlook on Highway S2, about 17 miles north of Ocotillo. And what you're looking at is Canyon Sin Nombre. And on the right of it, you have an area where you have what's called a nonconformity. And what it is an area where older sediments are actually on top of younger sediments. And if you look at the diagram on the left, that's what you're looking at, where you have older sediments below that are overlying younger sediments because of movement of the crust. And we talk about the formation of the Southern California mountains. And something that was very important in the geological history of this area is the formation of the Imperial Sea, which took place between about 3 and 6 million years ago. And actually, it's an extension of what we now call the Gulf of California that actually extended all the way up close to Blythe, where Blythe is now. And you can see Anza-Borrego, if you go through Split Mountain to the south side and look at the hills, you can see these formations called elephant knees along here. And what elephant knees are layers of sediment. This entire face that you're looking at are actually marine sediments formed by the Imperial Sea. And where you see these protuberances, there are layers of bivalve shells, oyster shells, that form a material called coquina. And if you've ever been to an oyster shell reef, you can see that generations of oysters make their shells, and then the next generation forms on top of them, and then the next generation on top of that, and so forth. And over time, with sediments get deposited on top of it, because it's greatly compressed, it forms a material that's very hard. You can still see the individual shells in the material, but it's actually compressed into a layer just a few inches thick. And where those layers are where you see these formations. And there's also another layer up on top here. And you can see other evidence. This is a sand dollar and a echinoderm, and then also a bivalve, a scallop. So once upon a time, it was a very different environment. After the recession of the Imperial Sea, the Colorado River ran through this area and formed a big delta. And we see a lot of deltaic formations in the geology of Anza-Borrego. And as the delta built up, it impounded water behind it, and it formed a giant lake that we refer to as ancient Lake Cahuilla, that is in the same bed as the Salton Sea occupies now, but it was much larger than the Salton Sea. And it was freshwater. And you can still see traces of the old shoreline. This is the west end of the Santa Rosa Mountains, and it's very apparent there. It's a perfectly level line, and corresponds with the sort of the high level of ancient Lake Kauai. And actually Lake Kauai came and went at least 3 times since the end of the ice ages, and perhaps more times before that, but the evidence has been erased. And in terms of the park is very rich paleontologically, meaning there are lots of fossils and plants and animals. And then one thing that I find particularly interesting are fossil footprint. And this is the footprint of a gomphotherium that was made about 2.5 million years ago. And gomphotheriums are ancestors to modern elephants, and then also mastodons and mammoths. And you can see the 3 toes right up here. And then also there are prints of a dog-like animal here, mammal, and then over here you can see prints that were laid down by a cat. And I just find this amazingly interesting. And then also we talk a little bit about migration. At several times during the past, there have been waves of migration of animals between North and South America along the Central America, the Panama Isthmus of Panama. And for instance, at one time we had giant, what we call now terror birds, which were birds that were over 6 feet tall, had a great big axe-like beak on them. They were the top predator here in Western North America. We also had ground sloths, and we still have armadillos and their relatives. In South America, carnivores such as saber-toothed cats and bears and wolves and coyotes entered as did also animals related to horses and to deer. And some of the other fossils that we have in Anza-Borrego, we had giant tortoises at one time. And this tortoise shell, which you can see in the State Park Visitor Center, is over 1 meter long. It's over 3 feet long. And then also we have, these are denticles, which are small pieces of bone that formed in the skin of giant sloths around the back of their necks. And so it was probably protection against predators like saber-toothed cats. And then also we had 2 different species of Smilodon or saber-toothed cats here. And then also this is the jaw of an imperial mammoth. And there are over 200 fossils of ancient elephants have been found in Anza-Borrego. So can you imagine what the landscape was like then? And this is a gomphotherium on the left, and this one had 4 sets of tusks, and then an imperial mammoth on the right, and an ancient horse, and a llama. And these are the drawings that Annie Kowalski did for the book. And then also a short-faced bear, which was the biggest mammalian predator in North America. And they were as tall as 12 feet standing on their hind legs and close to 1,000 pounds. So that's one big bear. And then this is a Smilodon, the saber-toothed cat. And well, we don't have many of those animals, those giant mammals hanging around much anymore. And what happened? They all seem to disappear between about 8,000 to 12,000 years ago. And their disappearance coincides with things that happened in terms of the environment here. One is climate change, that we were coming out of the last ice age and into the Holocene, our modern period. And as it did, the climate became warmer and much drier. Then also we had the entry of other mammals, such as the bison, that outcompeted some of the larger mammals for grazing and browsing. And then also we have the entry of human beings into North America, probably starting maybe 16,000 years ago. And they either brought with them or developed a culture called Clovis culture, which is typified by large fluted projectile points that were probably used to hunt the large mammals. And we talk about how the animals survive here. And we look at how animals both gain and lose heat to the environment. We talk about water and plants and how they lose moisture, but also how they get it from the environment. And we talk about the morphology of animals, that animals in hot areas tend to have long, slender appendages because they radiate heat more efficiently. And on the right, we have This is a desert black-tailed jackrabbit on the left, and then on the right is an Arctic hare, and they're actually in the same genus, but they're very different morphologically in that the jackrabbit has a long, slender body, and the Arctic hare, which is about the same length as the jackrabbit, is about twice as massive in terms of its weight. We talk about locomotion that's adapted to moving over loose substrates, such as hopping, where the force is directed down rather than back, and also sidewinding, where actually the part of the snake that's doing the movement is actually standing still, and the sidewinder pushes its front loop forward, and then when that's stationary, it pulls its back loop up to it, except it does that very quick so that it is a continuous motion. But it's adapted so that actually the part of the snake that's in contact with the ground is not actually moving. It's actually either pushing or pulling from that position. And we talk about something called a carotid rete, which is a sinus or a void spot in the skull of many ungulates or hoofed animals that live in the deserts. And it has two sets of blood vessels. One takes venous blood from the area of the nose where it's been cooled down by the exchange of air through the pathway, and then they commingle with arterial blood that's going to the brain. And what it does is it cools off the arterial brain, and so it allows the animal to have a hotter temperature in its body than it has in its brain. And so a bighorn sheep, its brain is about 98 degrees, but the rest of its body is up to about 104 degrees. And we talk about typical desert animals such as kangaroo rats and sidewinders. Of course, you couldn't talk about Anza-Borrego without talking about the bighorn sheep. We talk about plants too, and plants have basically two strategies for surviving out here. One is basically not to be here during the difficult times of year. And our desert annuals that put on the great flower show on good years, they're gone most of the year. They just exist in the soil as seeds so that they don't have to survive the rigors of the summer. And then we have other plants like the creosote, which has a whole suite of adaptations that allow it to live in very dry environments. Things like very small, thickly coated leaves that are both yellow, and so that it can access water at several different depths of the soil. And we talk about the morphological adaptations. And for instance, some plants have leaves that are tilted so that they're at an angle to the sun. And so the sunlight is spread out across it. And so the amount that place is also much less. And also plants like cacti that are succulents that have very thick stems allow them actually to store water over periods of time. And we talk about water potential, and plants really don't pump water through their systems. It actually moves passively, being that capillary action, the tendency of water to move through small spaces, and actually differences in water potential determine where the water will go within a plant, and brings it from the soil up through the roots into the leaves, into the stems of the plant, and then into the leaves, and from the leaves out into the atmosphere. And two typical plants are, again, the succulents like cacti, and then also phreatophytes. And phreatophyte comes from the Greek word for a well. And phreatophytes are plants that have very deep root systems. And in Anza-Borrego, several plants in the legume or pea family are like this, things like desert ironwood and palo verde. And they have roots that go way deep in the soil. And consequently, the growing seasons for those plants are not during the winter time when it's wet, but rather during the summertime. And the reason is that their roots are already in the water table down below, but it takes a lot of energy to get the water from the deep roots up into the leaves of the plants where photosynthesis takes place. And so that thermal lift is provided during the summertime when you have a lot of evaporation on the surface of the leaves. And we also talk about trophic pyramids and food webs, and that's basically looking at how energy moves through an ecosystem. That plants produce all the original biomass because they can photosynthesize. And then you have animals that eat plants. Then you have animals that eat plants. Then you have animals that eat the animals that eat the animals that eat the animals that eat plants. And so at each step of that trophic pyramid, you only have about 10% of the biomass at the step below it, because when we eat, we don't efficiently use 100% of the food that we get. A lot of it is used as energy so that we can carry on our metabolic processes and also move around, and a lot of it's just wasted as heat. So as you move up the pyramid, you have fewer and fewer animals in each one of those trophic levels. And as an example, mountain lions are few and far between and have to range widely to get food. And whereas, in most environments, plants, which are the basis of the pyramid, are found almost everywhere. And then also we talk about food webs, in that, talking about a trophic pyramid is kind of this nice conceptual way to think about how energy moves. But in real life, it's a lot more complex than that, that you have plants, that you actually have, animals like coyotes that sort of subsist at different levels in the food pyramid. They eat both plants and animals, they eat insects. And so it's actually a bit more complex than a simple pyramid. And we also talk about coevolution, how different plants and animals have evolved in either similar ways or in ways to take advantage of each other, to form sort of symbiotic relationships. And one example, of course, are hummingbirds, and then the red chuparosa plant, which is in the desert environment. And another one are bats. And bats are pollinators, and they usually pollinate at night. And the flowers that bats pollinate are usually big flowers. And there are two types of bats that pollinate. One are the bats that are especially evolved to do that. And these are bats can actually hover, and they tend to have long, slender tongues so that they can get the pollen from the flower. And then the other sort of bat are what we call face planters, meaning that they don't have the ability to hover, they don't have long tongues. So when they get to a flower, they just sort of plant their face in it. And as it turns out, actually, the face planters are far more efficient pollinators than are the bats that have evolved to do that, because they get more pollen smeared on their face, so that the next plant that they go to, they transfer quite a bit of pollen too, about 3 times the amount that the specialist bats do. And then we talk a little bit about predator-prey relationships, and some of the evolutionary paths that animals have taken. On the left is a caterpillar for a monarch butterfly, which is also the butterfly on the left of the pair on the right. And they have a very bold and obvious coloration. And in fact, they are poisonous. And so birds or other animals that eat them get very sick. And that only has to happen once, where the animal learns that, no, this isn't a good idea. Well, through evolution, other butterflies, the one on the right is a viceroy butterfly, have evolved to resemble monarch butterflies. And so where they coexist with monarchs, they get the same protection that a monarch does. And that's called aposematic coloration, apo meaning sign in Greek, and then somatic refers to the body. So their body is a sign that warns away potential predators. And then animals in the desert also have enhanced senses. And one is the tapetum lucidum. And I imagine that some of you at nighttime, as you're driving in your car, your headlight will shine on an animal, and you'll see the reflected eye shine that comes back. And that's actually the tapetum lucidum that you're seeing. And what it is, it's a reflective surface that's behind the retinas of some animals. And what it does is light will shine through the retina, it'll hit the tapetum lucidum, and it'll shine back through again. So animals that have those actually get twice the amount of light that we do. We don't have them. And so they also have that eye reflection that you see when they're in the light. Another adaptation we see in the desert are auditory bullae that we see in kangaroo rats. And basically they're just big echo chambers that are built into the skull of a kangaroo rat. And it enhances sound. It increases the range of sounds that the animal can hear. And it also increases the range in terms of how high or low frequency it is. And so, for instance, owls have double branched feathers. And so if you look at their feathers, instead of just one filament, that filament branches into, and that actually makes owls, when they fly, they produce less noise than other birds. And however, a kangaroo rat with its auditory bullae can actually hear the low frequency sound of a owl's wings beating. And so when an owl comes down and flares out just before it makes an attack, the kangaroo rat can hear that and then hops to avoid the owl. And probably everybody here has heard about tarantula hawks and tarantulas, and they have a reproductive strategy where a female tarantula hawk will sting a tarantula and it paralyzes it. And then they drag the tarantula down into a chamber that they've prepared specially and then lay their eggs on top of the tarantula. So the tarantula is there paralyzed, it's still alive, and so it's staying fresh. And then as the eggs hatch, the larvae actually consume the tarantula. But a lesser known relationship are creosote galls. And these, I find this just fabulously interesting, that if you've seen creosote bushes in the desert, you see that on them, you'll see these sort of leafy balls that form. And what those are creosote midge galls. And the gall is formed when a female creosote midge sticks its ovipositor into a branch or twig of creosote and leaves an egg. And besides just putting the egg in there, it also puts in, it has a little organ called a mycangia on its forelegs that it stores the spores of fungus in. So when it puts the egg into the creosote plant, it also injects the spores. And over time, the spores grow, and it's actually the fungus from the spores that forms the gall. And then it also forms a layer of fungus inside called a mycelium. And when the eggs of the midge hatch to form larvae, the larva will actually eat that mycelium. And then when after it metamorphoses into an adult, as it leaves the gall, it will take some of the spores of the fungus and put it in its mycangia. And then when it lays its egg, it will inject it. And what's even more interesting, and there are 15 different species of midges that do that, okay? And each species has an obligatory relationship with a species of fungus to form the galls. And to make it even more interesting, there are several species of wasps or sawflies that actually parasitize the midges, and they parasitize it by using their ovipositor and sticking it into the gall and actually injecting their eggs into the larva of the creosote midge. And so you have a parasite that's being parasitized by another insect, which is parasitizing a plant, which in terms has a synergistic relationship with the fungus, where both the fungus and the sawfly, the fungus and the midge benefit. And we also talk about the various different habitats that we have in the desert, from the pinyon juniper woodland at high elevations down to the playas and down in the flats. And we have riparian environments. This is the first palm grove at Borrego Palm Canyon, and this was a few years ago before it burned. And then also this is Coyote Canyon. And we also have creosote scrub, which is the most common vegetation type in the Western Colorado desert. And when I say Western Colorado, I mean, this is the desert west of the Colorado River. So it's the Colorado River Desert. And then we also have playas, many of which were actually lakes back during the Pleistocene, during the last ice age. We also talk about how humans got into the desert. I mean, we all learned back in grade school that, you know, the people that colonized North and South America came over a land bridge from Siberia. Well, as it turns out, there is new thought about that. And what it's been generated by is the fact that there aren't really there's not much archaeological evidence for this taking place, for this migration. And in fact, the oldest human settlement in the New World is not in North America. It's down here in Monteverde in Chile. And so a new hypothesis is that human beings traveled along the continental margins, taking advantage of marine resources, and came down the west side of North America and then moved inland in South America, and then developed the Clovis culture that allowed them to harvest resources from the large mammals, and then moved into North America. And indeed, the oldest archaeological sites in North America aren't in Alaska, they're in Texas. And so that has generated a new hypothesis. And this is an atlatl, which is was developed prior to the bow and arrow, and we have found atlatl darts in Anza-Borrego. And then also we see things like sleeping circles, and these are evidence of early human occupation going back as far as 12 to 15,000 years. And we also see more modern or more recent archaeological evidence. For instance, we see morteros and rubs, which are areas where plant food was processed by Indians that persisted into historical times. And this is also a hunting blind, and these exist in 2 or 3 places in Anza-Borrego, and they're usually on hillsides above passes where animals went by. And then this is a rock shelter down at Indian Hill in the south end of the park that's been excavated a couple times. And this is a wonderstone core, and wonderstone is a special type of rock related to chert. And if you strike it, long, thin sheets of rock will come off that can be shaped into tools. And so wonderstone as a material was traded all over Southern California and as far as the Great Basin, but it comes from the west end of the Santa Rosa Mountains. And so it tells us that Indians had very well-developed trade networks. And then also in the park, several places we have pictographs where fairly recent Indians have left evidence, and some of them are obvious. This is obviously a sun symbol here. Then I've also been told that these square symbols represent rain clouds, which I think would be very important if you lived in a desert. Okay, the future. As most of us are aware, our climate is changing and more energy is going into the atmosphere. And we often call it global warming, but that's probably not completely accurate. In fact, it's just that we're putting more energy in the atmosphere, and that can be expressed as heat, but it also means more moisture goes into the atmosphere, and also it moves around more. And so what does that mean for Anza-Borrego? Most of the effects of climate change are fairly local. And what's happening here is that there is a strengthening of the Hadley cell activity, the thing that I talked about earlier, about the circulation of air within the sphere. And that means that we're getting more high pressure systems in the Anza-Borrego area. So it's probably going to be warmer and drier in this area in the near future. And obviously that will affect plant distributions. And plants, we know that back during the Pleistocene, when we had alternating periods of cold and wet followed by hot and dry, that plants moved up and down in elevation and also north and south. Well, unfortunately, we now have barriers in our landscape, such as the city of Los Angeles and San Diego and San Francisco, that will restrict the movement of plants either north or south. And also we have certain vegetation types, say yellow pines in the very highest elevations in the Santa Rosa Mountains, that really can't move up any higher in elevation. So if the climate warms, those guys essentially sort of march off the top of the mountain and are no longer part of our environment. And as plant changes, well, so do animal distributions. And large animals that are mobile or can fly probably won't be affected a whole lot, but it's the smaller animals that aren't as mobile, that can't move across things like the city of Los Angeles or the city of San Francisco, that again will be restricted and probably limited in their amount of habitation. So what do we do as people? Does that mean that we should be doing things like moving plants and animals for them? Or maybe we should be doing something like trying to control the amount of climate change that's going on? And I also just wanted to say that the reason that Anza-Borrego exists at all is not because of the Department of Parks and Recreation, it's because of the people that have supported it and supported its formation and have defended it through time. That, every generation we get threats to this park, especially things like highways, power lines, and now water pipelines are constantly being proposed across Anza-Borrego. And each generation of park supporters has to support the park to prevent damages from projects like that from occurring. And it just within my time working in Anza-Borrego, the Sunrise Power Link was supposed to go right across the middle of the park. And because of public support, it was diverted to go to the south of the park instead. So that's what people can do as protectors of the park. So anyway, I think at this point, we'll open it up to questions. And I'm thanking the internet gods for not cutting out in the middle of that.
Wow, Mike, that was a tremendous, tremendous presentation. Thank you so much. And I do want folks to know that, this, you can just sense Mike's love for this park and Marie's. They know so much about the park and this knowledge that they've been able to just put in this book. It's just fabulous. One of the things I do want to mention about their love of the park, as authors, they are donating their royalties to the Anza-Borrego Foundation. Now, the foundation is the organization that actually supports Anza-Borrego State Park. And so when you purchase a copy of this book, you're actually supporting the park through the very generous donations that Mike and Marie have made to the Anza-Borrego Foundation by spending years working on this book and all of their efforts to support the park. I do also want to ask Rebecca. I believe she has some questions that people have sent in earlier. And Mike, feel free to see what you can say about the questions and give us some great answers. Rebecca, what questions do you have for us?
Okay.
So this one came in over email. It says, what can you tell us about the old Borrego area and all the dead trees there? I have photos of the area from the 1960s and the vegetation was lush and beautiful. I know the water table has dropped from overuse, but will that area ever recover?
Well, that's a good question. And the short answer is no, not for the foreseeable future. I mean, Borrego Springs is called Borrego Springs because we had water at the surface where old Borrego is. And those days are long gone. Now the depth of the aquifer in Borrego is in places deeper than 300 feet. And currently about 75% of the water that's drawn from the aquifer is used in agriculture in the north east part of the valley. And as long as that continues, the aquifer will not recharge, it won't recover. So we're sort of hoping that that pattern of use will change. I mean, eventually we'll have to because it'll get too expensive to pump water from grates to the surface. But it would probably, and another thing is that a lot of the water that was in the aquifer was put there during the Pleistocene, during the ice ages, when the climate was a lot wetter than it is today. So unless we get another swing in climate to cold and wet, it'll probably be a long, long time until the water's at the surface again in Borrego Springs.
I saw a question real quick. Somebody wanted to know where they can get and where the website is to order this book. It is on our website. It's sunbeltpublications.com. So you can go to that website and you'll be able to see a discount that's available there. The book is also available in your favorite stores, online stores, and at the state park. The state park has a store and other stores that are in Borrego Springs. But if you want to get the discount that we're offering, go to sunbeltpublications.com. Rebecca, do you have another question for Mike?
What have you observed regarding bird populations in Anza-Borrego with the current changes in the climate?
Well, that's a good question. In fact, we participated in the backyard bird count that just finished this Monday. And from my perspective, from 1977 to 2021, the big change I'm seeing now is that many of the golf courses in Borrego Springs are no longer being irrigated and no longer fill their water hazards. And so we used to get birds like snowy egrets and ibises into Anza-Borrego, and I haven't seen any of those lately since the water hazards on the golf courses have been dried out. So that's, in one way, that's probably a good thing in that it'll help to save water here, but also it's removed a piece of the environment here that was being used by plants and animals that have affinities to water.
Somebody wanted to know the name of the book. It's a natural history of the Anza-Borrego region, then and now. So that is the title of the book. Another question somebody wanted to know, is the park open? Okay.
Well, for day use, yes, meaning that there are, I think, 570 miles of jeep trail in the park, and those mostly are open. The campgrounds themselves are not, and that's to maintain, due to the COVID situation. But that's a relatively minor part of the park. You can go out in the field and camp just about any place you want to, as long as you're within a vehicle length of a road. So yes, that in that sense, the park is open, but the campgrounds and formal day use facilities are not.
Yeah, somebody wanted to know, where would you go to get more information about some of the threats to the park, so that if you wanted to become actively involved in helping the park, where would you go and get that information?
I would go to the Anza-Borrego Foundation website, that they're a pretty good clearinghouse for most of the issues that concern the park. And or if you live in Borrego Springs, just go talk to Mark Jorgensen.
And let's see, Rebecca, do you have any more questions? I'll give Mike one final question if you don't have one. Do you have one more for him?
I see one more. It says, is the ground in Borrego Springs subsiding due to pumping of groundwater?
Not that I'm aware of. But then again, it may be in some places. I just don't know. I don't have an answer.
And Mike, you and Marie, of course, have just been fascinated with this area, and you've spent so much time there. What motivated you to work on a book like this?
Well, we taught the class for 17 years, and we had all these lectures that were in PowerPoint, and we thought, oh, this should be easy. We'll just take the PowerPoint presentations and then just use it as an outline for a book. That was about 7 years ago. And as we found out, putting together a book, especially something that covers as much ground as this book does in terms of the different topics that we cover, it took a lot of, you've taught a class and you teach something, but you don't necessarily remember where you learned that yourself originally, but you need to make sure. And so we had to go back and recheck. And also, fortunately, we have a lot of people that we know and people who are friends who are experts in particular subject areas. And so we went back to those individuals to help us kind of round out the book.
And it certainly has paid off. This book is absolutely tremendous. We're so proud to have been able to publish this book, and then so proud of you to have written this book. And Mike, I know for years and years has been wanting to write different things. He wrote histories of different people in the park for the park newspapers and the local paper. And so he's always had this writing bug. And so this writing bug has paid off. And thank you so much for sharing your wisdom, sharing your love, and telling us a little more about Anza-Borrego. And again, if you're interested in this book, check out the website. We do offer a discount. And remember, when you buy the book, you're supporting Anza-Borrego Foundation and you're supporting the park. Mike, do you have any kind of closing thoughts?
Well, I just wanted to say also that, Sunbelt Publications has been a real boon to our region in terms of making information available to people. They publish a large number of books on different aspects of the natural and human history of this area. And so I would say go to their website and, of course, buy this book, but there are several other interesting books there as well. So I think you can really find a way to spend a lot of well-spent time.
Well, thank you for those very kind words. So again, thank you for joining us on the Sunbelt Spotlight, and come see us again. Check out our website, and you're always welcome to visit our warehouse too. We always have free books, believe it or not. We have books that are overstock, and we just don't like to throw books away. So we have a whole area. You can come in, take as many as you want, donate them to schools, whatever you want to do. But come visit us, check out our website, and most of all, visit Anza-Borrego, the flower. Hey, what's the flower situation? One final word. What's happening?
Well, we have yet to get a full inch of rain out here this year. So I would say it's probably not going to be a real banner year for flowers, but there are all sorts of other things to look at while you're out here. So I know that flowers get people out into the desert, but there's a lot more to see.
Absolutely. And again, thank you, Mike, very much for joining us for a Sunbelt Spotlight.
Okay. Thank you, Diana. Bye-bye.